Well, welcome to this third video on ConfirmaXL. The purpose of this video is to help folks download and install the software as well as all the point tools that you need to run along with it. If you might recall, ConfirmaXL, it's an IC design system. It's really a framework with a lot of custom software that works in conjunction with uh, a variety of third-party tools that we've collected and made to work together to pretty much emulate what you see in commercial software, like for instance, Cadence Virtuoso platform, or tools from Mentor you might see, or Synopsys. Um, so again, though, because it's composed of a variety of tools, there's several steps in the installation process. So not only do you have to download and set up Confirma XL, but then you need to also download and install the point tools. And there's about 7 or 8 point tools, depending on what you want your flow to look like. So it's a bit of a process, but it's not too hard. But I think if you stick with it and go through it, once you get it set up, it's pretty easy to use, and I think you'll be happy with it. There's a script here, but I'm not really going to stick to that. The first thing you need to do is though is go over to the Confirma web page where it's available. And the name of that page is www.microcosm. It's ucosm.net. So if you go over to that page, there's a lot of description of what Confirma XL is and what you can do with it. You can read that on your own, but where you want to go is to the download page, and that's over here on the right. So if we go ahead and do that, I tried to write a pretty thorough step-by-step set of instructions, and hopefully they're understandable and they're easy to follow. Um, but Confirma XL itself, really, there's no installation program. What you need to do is you need to download 5 different folders that are zipped together. So you need to download these folders, unzip them, and then you need to place them on your hard drive in an appropriate location. And so really what you want to start off with is creating these folders where these Confirma folders have to go. So I think this is the easiest way to go. So if you start off and you create these first 4 folders um, on your hard drive, so that would be CY drive, CY drive tech. That's short for tech folder, technology folder. We usually put PDK information in that. Then also CY drive process. So there's some specific process PDK folders that go in there, and I'll talk about that a little bit later. And then this C uh, uh, Y folder, and that will be a placeholder for Spice simulation data. So when you get to the point where you are simulating your schematics, you want that Spice data to go in a specific location so that you can manage it well and clear it out when you have to. Um, so that's really it. Those are the 4 folders you need initially. So once you have that set up, then go down to step 2 here. These are all linked together. So all these folders exist on our Google Drive. So that's how we're doing the distribution. And so hopefully you won't run into any problem here. We did have some problems initially where the permissions weren't set correctly, and it was requesting a email permission, I believe it was. So hopefully that should be fixed now, and you should be able to download these files in a straightforward way. Now, some of the files I'll say are kind of large, so you may get a message that Google can't check them for viruses or something like that. Just download them anyway, you'll be fine. So this first one here, CXL, and by the way, that's shorthand for Confirma XL. So CXL Confirma XL.zip, that's the software, excuse me, that's the folder where the actual software is, where the binaries are. So you download that to a temp drive. I made a temp drive to test this and downloaded all these. So this is the Confirma folder. This next one here, um, cxllibs.zip, that contains a lot of libraries for you to use. So there's symbol libraries to work with Kicad, and then there's also a lot of Spice libraries, things like behavioral modeling libraries that operate on Spice. I think people will find that quite handy. This one here, CXL PSMG PDK. So we're distributing this with initial PDK. It's Predictive Semiconductor Modeling Group. So this is a predictive PDK that emulates a 180 nanometer semiconductor process. So if you're using TSMC or TI or CIMIC or one other 180 nanometer process, but maybe you don't have access to the PDK because of NDAs. We certainly can't distribute those kinds of PDKs because of the NDA problem. So so we decided to put together our own so you can get started right away doing IC design with Confirma. Um, so again, that's been tested. It models very well against commercial foundries, and we've tested it on Topspice, NGspice, and Xyce. So it runs on all three of those simulators. So any HSpice simulator should run just fine on. So hopefully that'll help folks get started. This one here, CXL My Chip Designs.zip. So this is a folder where it's set up for an initial project, and it kind of outlines a design methodology I think will be helpful, especially to those who are new in IC design. But it's a place to do some initial simulations. So there's some simulation examples. I'll talk about that a little bit later. And then CXL My Chip Designs sim folder. That's a simulation folder that's set up to reflect the project folder. So you need to download all five of these folders to a temp folder, and I can see I'll show you what that looks like when I did it myself. So all these folders have been downloaded to my temp, and you should unzip these one at a time. So after you unzip it and move it to the right location, it's probably best to clear out your temp folder or back it up somewhere else so you don't get the various folders confused with each other as you install them. So just as I said, unzip them and then follow these instructions. So for instance, the ConfirmaXL folder with the software, you have to place it exactly as shown. So place it at C ConfirmaXL. And similarly, for these other ones, just please follow the instructions here. They're very specific. If you do it this way, all the configurations that you get with this first round of Confirma will work just fine. You can move these things to other folders later on, but then you have to fiddle with the configurations in Confirma. And it's not hard, it's just an extra step. And I think you can avoid some trouble if you just do it this way, and you get the satisfaction of pulling up a schematic right away and performing a simulation. And you can see it. You can see the simulation run on NGspice or Xyce or whatever spice engine that you install, and that's satisfying. You want to see that. So let's see. So that's once you get to this point now, Confirma is installed. So you're in good shape there. Now, step three involves downloading the third-party installers for these point tools that we're using. So again, I would encourage you to install it exactly as shown here. You can use these installers for the exact versions of the third-party tools that I'm using. So all the setups will work. It's pre-set up for you. You can later on go to a different version of NGspice, for instance. I think there is a newer one. But if you do that, you have to make a setting change in one of the Confirma forms. It's not hard, it's just an extra step. One thing you can't compromise on, though, is you have to use this version of Kicad. So you need to install this version. I'm pretty sure Confirmer will only netlist with this version at this time. At some point in the future, I'll go and update things to work with later versions of KiCad. But really, we're doing IC design, and this version of KiCad works just fine. We're not dealing with all the PCB related stuff. KiCad's a very nice program, by the way. I think folks are really going to like it. And there's nothing really special about doing schematic capture for IC design. But you do need things like hierarchical symbols. You need buses, multi-bit buses, and buses through symbols. So we wrote a lot of software to make all that happen and to make the net listing work correctly. So it should be a very Cadence Virtuoso-like experience, though, I believe. So go ahead and download all these. K layout is one. You may or may not want to download lazy. There's some script stuff we have going on that for later on. It's not ready yet, but I fiddle with a lazy. It's old, but it works pretty good. Topspice, you definitely want that. So download the demo version. Um, this is the installer for it, or you can go over to Penzer if you want and download it there. Get the version because the demo, not only do you get Topspice, but you get Topview, which is the waveform plotter, and you definitely want that because Topview will read not just Topspice, but it will read data from NGspice and Xyce. And so long as you output the data in raw format, like Hspice raw format, but it works really well. I mean, it's not perfect. No plotter's perfect, but it does have a Smith chart that works really well. So if you like to do RF design, you want that. So another one is QSpice. I think it's best you go over to Corvo to get QSpice. So I've run it in this framework. There's some incompatibilities with Hspice. So some of these spice primitives for Hspice, it's very small differences. So I've run into some problems once in a while. It just means that you have to be careful in the primitives that you use for QSpice, but it runs just fine after that. So if you pay attention there, you can get it to go. We'll probably do something custom here to help it along. So uh, people who want to use QSpice don't fall into these traps. All right, so let's say you got these downloaded, and just once again, I'll see if I can show you what that looks like when I did it. So here's temp with the confirmer stuff in there. I went ahead and made a temp 2, and these are what the installers look like. And then again, I installed one at a time. Once I installed it, I cleared that related material out. And you can pretty much install it where the installer wants you to put it. So so once you have KiCad uh, installed, there is a little bit of configuration that you have to do. And really, it just deals with the symbols. So just like any schematic capture program, you have to have access to the right symbols. And so there's a lot of symbols that go together with ConfirmaXL that we've provided. And you can install these symbol libraries one at a time, but I think an easier way to do it is to copy over a symbol table file that you get. So let me see if I can explain a little bit better what I'm talking about here. So let me go ahead and open up. This is a little tedious, I have to admit. So let's see. So go to the, uh, let's see, C. So go to your C, and it's kind of funny where this gets installed down to users. And Windows gives you a username. Mine happens to be KGFAI. So click on that, and then go to App Data, and then go to Roaming. And down in Roaming, you'll see KiCad. And let's see, I believe you want to go to this one, 6.0 will be installed. And this is it here, symbol lib table. So that contains um, all the symbol libraries that KiCad installs with, and there's a lot of them, and they're mostly oriented towards PCB design, and we're not at all interested in PCB design. So as part of Confirma, you get a whole bunch of symbol libraries, and in addition to that, you get a pre-installed working area, and we're going to hop into that for a moment. Sorry for the little bit of tedium here. So Y drive, C Y drive, go to my chip designs, and go to this one, PSMG and P180. So that's 180 nanometer. This is a working folder to do some characterization on, so you can run some experiments on this 180 nanometer process. Then go to designs here. And designs is where all the working folders for the designers who may be on the project. And there's one here. So there could be as many designers. I don't know how many designers you'll have on your big IC design, but this is how that gets set up. So all designers are under designs. And within that, so down here, guest working. Let's see. So this is where things like schematics and symbols are for that particular guest workers. but I'm going to go here, Kicad symbol table. So every designer who has a working folder also has a Kicad symbol table. And this one ships with Kicad. And it's all you need to do is take this one and just drag it over and copy over the one that's there. So I've already done that. My stuff is installed. But if you do that, then you'll get KiCad with uh, all the model library, excuse me, all the symbol libraries are already installed. So I have KiCad up and running already. So I'm just going to show you real quick what that looks like. And again, sorry for this bit of tedium. So so we're in KiCad, we're in the KiCad symbol editor, and these are all the libraries that have shipped with ConfirmaXL. So for instance, here's the Spice library, excuse me, here's an RF Spice library. The devices, these are the foundry models. So this ships with PSMG, P180 nanometer. These are all the devices that you get with that. So it's all pre-installed. So let's see, so we're gonna click on one. CV. So this is core voltage NMOS. So it's an NMOS transistor ready for you to use. Um, so that's really the extent of the KiCad install. So let me drop out of there for a moment. So it's a bit of a roundabout that we went through there, but I think it's worth it. I think it is worth it rather than trying to install all these one at a time. And there's a way to do it. It's once, by the way, once you have the initial setup going, then making a modification, adding or subtracting a library is much quicker. Once you have the initial install, that's very fast. Let's see. So it does look like I have forgotten something here. So um, let's go ahead and um, since we have Confirma installed, and I should have mentioned this as well. So let me go back to let me go back and open up a C drive. Let's see here. Here we go. Okay. So if I followed all the instructions, I should have a Confirma folder, Confirma XL folder in the C drive. And when I look in there, there should be a shortcut. Here it is to the executable. And so you do want to just drag that onto your desktop. So once you do that, then it's easy to start Confirma XL right from the desktop. So let me go ahead and do that. Okay, so we've installed Confirma XL. We've installed all those other folders, working folders and working areas and PDK libraries and things like that. And we have KiCad up and running. Um, so we're in pretty good shape. Software started all right. So, but there's another step in terms of installing um, KiCad and making it work smoothly with Confirma XL. So there is this feature. It's called Pass to Confirma. So Um, and what that means is, so Confirma, it started up and it started up with an initial cell. It's this cell here, initial design T underscore GST. That's for guest, by the way, underscore inverter 1X. So it opened with an initial cell. I'm going to open that. I'm going to say open. Okay, and you can see that started up in KiCad. So that's pretty nice, right? So you got the path from Confirma XL to KiCad. You'd like to have the path in the other direction. So, for instance, I have this other test bench. This one happens to be characterization of uh, varactors and memcaps for the PDK. So I have two different test benches, and I want to be able to like easily and quickly move from one test bench to another, and that's called pass to Confirma. So the way that works is you've got an icon here. It's called BOM, Bill of Materials. That just happens to be what uh, the KiCad team named that. But if you click on that, there's this little pass to Confirma script. And so if I select that and I hit generate, what happens, we'll see what happens. It passes that test bench and loads all the information associated with that into Confirma. So now you're ready right away to sim with that new test bench. So you'd like to have that pass to Confirma script up and running within your KiCad. And that way you can easily move back from, you can switch from Confirma, open up a schematic in one direction in KiCad, and then in the other direction, you can go past the Confirma. So how do you do that? So go back over here, and it's a little odd. I had to remind myself. Um, so uh, we're going to add, there's already two pass confirmers because I did a demo before. We're going to add a new pass to Confirma XL, exactly the same as the other one. So this is what you do. You hit the plus sign here, it pops open, and it wants you to tell it where the script is. So the script is C Confirma XL bin and go into debug. Sorry about that. And just hit pass to Confirma XL and say open. Okay, and now you need to give that generator a nickname. So we've already given it XL and XL2. We're going to give it XL3. Okay, all right. So now we got XL. There's one more step. You have to go into the command line here. You only have to do this once, and then add the %B, and that's for block. So then if you hit generate, okay, you'll see that that worked. So test that. Okay. So now we have that third pass, same as the other ones. There's one last step. And when you do this for the first time, you'll want to, test it and then close it and then shut down KiCad. This is only for the first time. And that ensures that that script command will be written to wherever KiCad places it. I don't know exactly. Otherwise, you'll see you'll be missing that. So you need to enter the script, run it at least once, and then shut KiCad down and then start it again, and you should be good to go. Okay, so I think I think that's most of it in regard to installing the software. We've gone on quite a bit. I think one thing that's useful to do though, real quick, and I think it makes sense to do that, is let's take a look at the folders that we installed, and so you can get a feel for where things are. So I'm going to go ahead and pull up a C folder. And so again, Confirma XL, that has all the software. And by the way, FaceIn, that's a filter program. So if you pop in there, and hopefully this will work on your system, this is a free filter software program I threw in there. So you can do lumped element and distributed element filters. Um, it's old, but it still works well. I still use it quite a lot. So that's where Confirma XL is. And then recall that we installed this Y drive folder. Okay, if you pop in there, you're going to see these three folders here. This one's my personal one, Microcosm Chip Designs. You won't get that, at least not yet. The tech folder will go in there first. So that's our technology folder. Under process, that's where the PDKs are. So here's the PSMG PDK. There will be other nodes that will be coming. So right now we're starting off with 180 nanometer. So if you pop in there, this is where a lot of the data is for this PDK. So if you pop down into models, that's where all the Xspice model files are, and they're broken up to make them easier to follow and also to troubleshoot. If you've ever looked at Xspice model files from fabs, they're pretty tough to sort through, and different fabs do things different ways, and it can be tough. If you double click on these, and if you have Topspice installed, even the demo, it'll open up immediately in their editor, and you can see all the model files for that particular style of transistor. So there's core voltage transistors, low voltage transistors, high voltage transistors, MIM caps, MOS caps, resistors, all that kind of thing. Um, so it might be worth looking around in there when you have some time, or if you're new to IC design, that'll help get you started. Also, under devices, this is the other area that's a little bit interesting. So devices is where the symbols are for the KiCad symbol library. It turns out that unlike other CAD software, like Cadence Virtuoso, I guess, and some mentor tools, where they put all the symbols in a different, in a separate folder or sort them in some way. Uh, what KiCad does is it puts all the symbols in a particular library in a single file. So devices.kicad underscore sim, that is the symbol file that contains all those symbols for that library devices. So that's associated for the 180 nanometer devices library. So those are all the symbols there. You'll notice that there's other folders, sim. Normally you would think that's all the symbols, and it is all the symbols, but that's for ConfirmaXL only. So sometimes if you're moving symbols back and forth across libraries, to get the symbols from one KiCad symbol file to another one, we have to decompose that, and we do that in this folder here, and then we reconstruct the symbol file. It's kind of a pain, but it seems to work okay. We haven't had any trouble with it, but that's the purpose. So you don't want to get in there in the symbol folder and fool around in there too much. You can look around if you want, though. And then schematics, these are all schematics, and so these are all the KiCad schematics. So that's where they're kept for the devices. So what you'll notice is as you come up to speed on this, every every working folder or every symbol library, they share all these things. So I'm going to go ahead and go back to Confirma for a moment here. When you look on the bottom here, you'll see this my working folder. So um, I'm kind of going off on a tangent here again, but if you open that, you're going to see um, you're going to see where this guest working folder is set up. If you look in there, so that if I was a guest, I could go in here and I could start doing designs. And if I look in that working folder, and every designer has a working folder, you'll see these other. You'll always see this. You'll see a place where the symbol deconstruction is done, as I just spoke about, and then this is where all the guest schematics would be. So, so take a look in there, and some of this is in the documentation. So you'll want to look through the documentation to come up to speed a little bit if you're interested in the file structure. And there's other things like Spice circuit schematics, excuse me, netlist, that sort of thing. So you want to see if you can come up to speed on that a little bit. It's not too different from what you see in Cadence. Okay, so um, since we're here, why don't we go ahead and do a little simulation? So I'm going to take this test sheet, and it's full of inverters and things, and current setup is uh, MOS and MIM capacitor verification. So I'm going to pass this over to ConfirmaXL. So let me go ahead and do that. So we pass the bench over, and let me close that now that we've passed it over. And so you can see some of this was in the first two videos. Um, so when you've done that, it's updated the hierarchy off the top page. So hit a hierarchy again. You can see these are all the inverters and things that are on this first page. And there's also another thing you should note is there's this multi-index tab interface. So there's this include, and there's Spice netlist and so on. So if you hit the Spice netlist tab and you hit fast netlist, this extracts the Spice netlist from the schematic. And so long as you have a simulation set up, so let's see what do we have. You can go over here and choose analysis, and I'm going to go ahead and set up a little simulation here. 10 micro, I think that sort of do the trick. I don't think we need such fine resolution on the step. And I'm going to say enable transient, and okay, I'm going to save the setup since I'm here. Okay, and so hopefully if I did this correctly, let's go ahead and do a quick simulation. Okay, so just verifying that we have, oops, excuse me, I didn't mean to do that. I meant to hit the plots. And so we have Topspice with Topview installed, and we actually just ran Topspice. So I'm just going to plot one waveform here, see what it looks like. Okay, so this is some inverter on the page, so we'll go ahead and close that. So at any rate, I guess the other thing, so we just ran this simulation, and you might be wondering how you navigate. You have this hierarchical search function here. So is all you need to do really is just select one of these guys who might have an underlying schematic, and then you can view the schematic. Okay, just hit that and view it. And it's similar, a similar methodology when doing layout. So I've got KiCad and Lazy set up. So let's take a quick look to see what we have set up. So there's under this setup, these were all the forms for setting up the various point tools. So if we pop down to this one here, we're going to go to the IC layout, and it looks like I have KiCad, but I'm going to switch over to Lazy, and I'm going to say save. Okay. And so then I'm going to say, I have a couple options here. I'm going to view the layout from my working layout folder. So that's what that's about. And this is telling me that the cell does indeed exist. So if I go ahead and click that, and it should default. Okay, so there's your layout. Um, and then as you might suspect, if there's a cell there, okay, I have K layout installed. So let me hit save and close. And now let's see if we can open up the same cell in K layout. And this tells me that the K layout GDS file, they're different file types. And let's say OK. And now for some reason, K layout seems to take a little longer to start up initially. So we're waiting for that. Waiting. Okay, here we go. Okay, so there's the same cell, a GDS for that. Okay, um, so the point of that though too is if you do things slightly different, you may have to get in here and change paths. Here's the again back to the layout tool window. So this all seems to be set up correctly for lazy. It's working, but there's this. This is how you would make that connection to lazy, and then it's similar for K layout. So here's something you need to be aware of. When you install K layout, it's going to put it in um, that app data folder that we saw earlier with KiCad. And so you will definitely need to change this. So KGF FAI, that's my Windows username. You need to see what your username is, and then you need to replace this with yours. And then if you do that, then you'll have the correct link to K layout. But you'll definitely have to make that change. So I'm glad we took a look there. Okay, so I think I think this is enough for now. I can see we're going on 40 minutes, so that's longer than I thought. So um, if you have any questions, uh, please put your questions in the comments, and I'll do my best to answer them. So it's not too bad, but let's face it, it is IC design. IC design software can be tricky to set up. There's a fair amount to it. On the other hand, though, um, I think you can do this without a full CAD department. It's something that it's very difficult to do on tools like Cadence. So hopefully you'll find this video useful. Hopefully you can get it going. I'm pretty confident that if you get it going, you'll be, simulating in no time. You'll have your own suite of software, which is really terrific. So you'll always have access to your IC designs. Um, it's really a powerful thing to have as you move through your career. I can't emphasize that enough. You want that, even if you choose something else. You want to have your own design flow, and you do that, you'll have a successful career. Okay, well, thanks very much. I hope this was helpful. I'll try and make some more videos in the future. There is a lot to talk about. There's a lot you can do in RF design. We're doing all kinds of things. So there's also some more back end setup. We're trying to get the Global Foundry PDK up and running. So we do have the Global Foundry models now running on NGspice. So we have symbols that are available in Confirma Kicad setup, and we can drop down transistors and we can simulate them on NGspice. We're still having trouble getting them to go on Xyce for some reason. I don't really understand that problem, but we're having difficulty. Um, and then I think we'll do IHP and then maybe Sky also. We'll try and get all those PDKs up and running. And we do strive for design reuse. So we try and make all the symbols same symbols, and we do some mapping tricks to map the symbols to the different libraries. And that way you can reuse your schematics and things like that. So, okay, so there's a lot coming. Hopefully this was helpful. And thanks for sitting in for so long. Thanks for considering Confirma. And we'll see you next time. Okay, bye.